Yeah, in the last session we completed the end-to-end pipeline, e-commerce sessionization. We completed this, but we only saw in the local mode. I will also showcase the same thing with the automation, which will be using Cloudera, Oozy, and AWS. I will be showcasing on the AWS so that you can get to know how this end-to-end automation works, orchestration of your Hadoop project works. Now few things are pending in Spark SQL. With the e-commerce sessionization, we also saw how to integrate your Spark with Hive. How Spark can read and write the data into the Hive table. So that we saw. But there also exist independent programs. So if you want to try it with simple examples, with for Spark integration with Hive, you can use this. Go to the Spark SQL project, and you can go to the testing folder. Inside testing folder, you will see Hive. But all these things I have shown as part of the project itself. But just for to look as an independent program, how it looks like, how read write operation works with Spark integrated with Hive, these you can look into. Simple examples, but I would recommend to understand the end-to-end projects, Spark and Hive integration. So few things are pending. As I said, I would be covering user-defined functions. So and user-defined aggregate functions. So first we'll see user-defined functions. These user-defined functions are simple functions. User-defined aggregate functions are a bit complex comparatively with the user-defined function, but it's not so complex. We can write the user-defined aggregation functions. Comparing with the Hive and all, the user-defined aggregation functions, Spark UDFs are but bit simple. So what do we mean by UDF? UDF we mean by it means user defined functions. Suppose you want to apply some logic on your row. So we have a data frame here. Let's say we have a employee data frame. Name we have, age we have, city we have salary. 10K salary, 20K salary, something. 15K, 12K, 18K, 30K, something. These are our salary. Now let's say I want to increment the salary by 1K something. So this data frame should how it look like. After you transform the data frame, again everything will remain the same: name, age, city. Salary will be different. It will be 11K. It will be 21K, 16K, 13K, 19K, and 31K. So user-defined functions are doing these kind of custom processing. Whenever we want to do some custom processing, so we will use these user-defined functions, which are not built in our in our Spark SQL. So here we will have to just write a simple, we have to define a simple function increment, then use it in your Spark SQL or data frame API. And there are steps to do that. The idea here is everything cannot be solved by the relational style programming. You cannot solve everything with the select queries, all those things. You sometimes need to write some actual program and incorporate that actual program into your SQLs. So those things require your user defined function. So the steps are, you have to write user defined function similar to Hive it is. Register user defined function, use UDF in Spark SQL or data frame API. I mean, I said that you can process the data in two ways, by writing the SQL queries or by writing the data frame APIs. So in either way, you can use your user defined functions. So I will showcase a simple example of how to write a user defined function. So if you go to the Spark SQL project and search for Control-Shift-N, search for UDF examples. So what I'm just trying to do here is, we have our sales.csv file. We have our sales.csv file, and these are all our records. I just want to increment the item value by 50 rupees. It is 100. I want to make it as 150, 555, 560, 650. I just want to increment everything by 50 rupees. So what we will do is, we will define a function as we are seeing. We are defining a function here, increment, which takes a double because our column type is double. The item value column type is double, and we just add that value here. Nothing we are doing here, as simple as it looks like. Now we need to register this we have to register this function, and that's what we are registering here. As you can see, once you create a SQL context, you use the UDF and you say a register. Now when you are registering, you can see you are doing something else here. So you just called my increment function, which is the same function, and you are placing underscore. Now this is a new syntax. What is this syntax actually? Now this syntax is actually a Scala syntax, and this is called as partially applied function. We'll just go back to Scala and understand what is partially applied function. So let's say I define a function called product. We'll just say x. It takes integer, it takes one more parameter integer, and it just says x star y. We are just multiplying the two parameters and returning that result. So product of 4 comma 5 is nothing but we get the 20. Now there is a concept called currying in Scala. I don't remember whether I have explained currying, but currying also is one of the concept. I mean, it's a syntax actually. There is no concept behind that, but it is a syntax, and that syntax is useful in partially applied functions. Now, just what is currying? So currying is nothing but instead of defining your function in this fashion, we'll slightly change the way it is defined. Product we can pass x as integer and one more parameter group you define. So this is actually currying. So instead of defining in a single parameter group, we say it as multiple parameter group. This is one parameter group. This is one parameter group. So that's what we call as currying. But you can the logic can remain the same. It's only how your parameters are grouped together. So you can have multiple parameters inside one group. We can say a again int. You can have b again int, and then you can just say x star y plus a star, something like this. So this is called one parameter group. This is called one more parameter, and the whole expression is called as currying. The concept is called as currying. So I will just, yeah, here is a question. The question is any advantage with currying over one parameter group? I don't see much of an advantage here. It's only the syntax that is being used. I mean, these currying is used for some other purpose. The idea here is, let me explain the partially applied function. So there it is being used. It is being used there. Otherwise, not much importance is there to this currying. So the way it is called is a comma, I will just say 2 comma 3, then we will have 4 comma 5, anything. So this is how you call a currying function. Currying function. Now let me take a simple currying function just to explain what is partially applied. I will take a simple currying function. This is one parameter group. This is one more parameter group. So when I say this, the way I can call this function is product 4 and 5. This is how the currying works. Now what is partially applied function? Partially applied function is nothing but, the name itself says you apply it partially, meaning when you call this function, you need not pass all the values for the parameters. You hold back few of the values for the parameters. You partially pass few of the values for the parameters. So here I don't want to pass the second value for this function, the value for the second parameter. So So when I don't want to pass and I want to hold it back, I just specify underscore. So this is what we mean by partially applied function. This is what we mean by partial. You are holding back the second parameter value. Now what it returns when we apply partially applied function, and when we call the partially applied function, it returns a function object. Now ABC is a function object. As you can see, its data type says that it takes an integer and it returns an integer, meaning this function you can pass one parameter, that is nothing but that we had held back. Whatever value we had held back, we can pass it now. So ABC, I can pass it is actually the second parameter that we are passing. It will multiply 5 with 4 and you get the 20. And this is one of the use case of currying. This is one of the use case of currying. You can get the partially applied function, meaning from an existing function you can get the function object. Now what is the use of partially applied function? What is the use of partially applied function? This is what we have seen now. So we have defined a function. We have defined the function, but this register function, some function in the downstream, it wants it takes a function, but in the form of a function object. It wants to take in the function object. So what we can do is we can call that function and don't pass the value. So in which case it will return a function object. A function object will be passed here. So this is the use case. The generic idea here is you define some function here. The generic idea of partially applied function is you define some function. It takes some x comma y parameters, and you want this function to be passed in the downstream of your code. Downstream of your code there exists some some function, higher order function 1, which takes a function here, some normal parameter, and let's say it takes a function. But this function takes only one parameter. Let's suppose this function takes only one parameter. But whatever function we have, that the logic that we want should be same. I mean to say, our logic matches. Our logic matches, and we don't want to create a new function so that we only have one parameter. So from this we can get a partially applied function, and that partially applied function we can pass it here. The idea is that you have defined some function, but the parameter doesn't match. The logic is matching. So logic is matching, but how can I pass that function to this function? So with the help of partially applied function, you can pass this function here. So I hope you got a picture of where this partially applied function can be used, and we also have one example. This is where we are using partially applied function. Had we defined a function object itself, then this would have been not required. We could have defined a function object itself directly. We could have defined a function object itself, which takes So we could have defined a function object itself. We know that this is how we define a function object. You assign a literal, you assign a function literal to your object. This is your function object. You can directly pass this function object. So either we do that, but let's say we already had the definition of our function. Somewhere in some class somebody had already implemented a function, and that was useful for our application. So instead of rewriting that function once again, we can make use of partially applied function. And get the function object from that. So that's the idea here. So I hope you got the meaning of partially applied function. So we just took a diversion from user defined function, and we learned about currying, and we learned about partially applied function, and also the use case of currying and the use case of partially applied function. Now coming back to our user defined function, as I said, we have to write a user defined function. We have to register the user defined function so that it could be used in the Spark SQL or Spark Data Frame API. Now when we register it, this is how we register, and we specify our partially applied function here, and this is nothing but this name will be used in your SQL query. So this name will be used. You can say select customer ID, and then you can say my increment. So it has to be this name. I mean, both are same. I have given. I can say INC. So it has to be INC. Incremented by 50 rupees. So that's how the user defined function works. Any custom function you want to write, you have to write a user defined function where it manipulates each row and returns a new row. For every row there will be a modified row. For every row there will be a modified row. So that's how you get a user defined functions. Somewhere some error is there. Okay, just to showcase the type safe. We need to specify the input parameters. I think I did not specify. Local as the first parameter, code source main resources sales.csv. I think we are reading sales.json file. So we'll give the sales.json. So it has exited with code 0, meaning we have done that. So as we can see everywhere, 50 rupees has been added. 50 rupees has been added. So that's how you write a user defined function. It's bit of a simple. Any function defined already, you can use it as a user defined function with the help of partially applied functions, Scala concept. Now we have used this user defined function in the SQL query. We have used this user defined function in the SQL query. Now how do I use it in the data frame API? So when you use it in the data frame API, it's slightly different. I mean, very slightly different, not too much of a difference. These two steps remain the same. You write a user defined function, use user defined function in the your data frame API, but the way you register is slightly different. Let me showcase. I think that is the default nowadays with Spark 2.0. I haven't checked this user defined functions, but we'll see the Spark 2.0's user defined aggregate functions. The way you register here is slightly different. Again, it's almost same. Let me showcase that. So you have to say, if you search for user defined function, we saw user defined examples.scala. So the one more is user defined functions, UDF function.scala. Now open that. There also we are applying the same logic. There also we have the same method definition. The only way we register it, we don't use the SQL context dot UDF dot register. We just say UDF. We just say UDF. Now where does this UDF exist? This UDF exists inside this functions. You will find a lot of functions in this functions package. Earlier, if you remember, we saw monotonically increasing function, array functions, lot of functions you will find. You have to just search for that. Most of the functions are already available here. So one of the function is again UDF function. So we just use that UDF. Just keep in mind, because it will never prompt you. If I comment this, it will never prompt that you have to import this package. You will never know how to import this package. What I'm trying to say here is, so when I say now as you can see, it is prompting you. As you can see, it is prompting you in this fashion. Now when it prompts you in that fashion, it will automatically import that. It will automatically import. So such kind of prompting is not there in the IntelliJ for UDF. It will never prompt whether you have to import it or not. So you have to remember that these things exist in the SQL.functions. You have to remember those things. So it is, the error has gone now. Now you register in this fashion, and whatever it returns, whatever this function returns, so this you will be using in your data frame API. So this you will be using. You just say data frame, select customer ID, amount paid, and amount paid as increased value. Now as you can see here, there is one difference here. We are using a dollar symbol. We are using a dollar symbol. So that's a new thing that we are saying. So if you see, I mean, we had also seen in the project. I can also say val x equal to select sales df dot select. I can write in this fashion also. I can write in this fashion also. But why I am explicitly specifying a dollar symbol here? Why can't I remove the dollar symbol? So all of a sudden it throws some error. If I remove the dollar symbol, it throws some error. Because the idea is that's how select method has been defined. So if you hover on the select method, so if you see the definition of that select method, it expects a string. It expects one column and multiple columns. Call colon string and calls colon string star. When we say string star, it is nothing but we can give variable number of arguments. Variable number of arguments. So here at least there will be one column and then variable number of arguments. But that is not important. The important is both are of the type string. Both are of the type string. So we are just providing the string. Now when we use a user defined function, it does not expect a string, it expects a column. Whatever we pass as a parameter should be a column object. And this dollar symbol, if you see this dollar symbol, is again a function. It is just a function which takes a string and returns a column object. String, as you can see, it is defined as string to column. So because user defined function expects a column object, it does not expect a string object. So this dollar symbol converts a string to a column object. Now if user defined function expects that, then I can remove it from our normal thing. But still it gives the error. Because that's how the select function is defined. If you hover on this is a overloaded select. As you can see, it expects everything to be column. It says calls of column star. So it expects everything to be column, hence to every column you have to attach a dollar symbol. So I hope you got the difference here. That's how the select method is implemented. They don't have a method implemented with which takes one parameter as a column object, one more parameter as a string object. Either it takes all as string objects, or either it takes all as column objects. So that's the reason we have to have dollar symbol. And dollar symbol is just a function which converts your string to a column object. That's all. And again this is also available again here. Sorry, it's there in implicits. So this you will get only from the implicits. If you comment that, you won't get this methods. So this is also important. Some methods are defined there, and dollar is one of the method. So this is how we use in data frame API. So let's run this program. We should get the same result. Local code source main resources sales. Are we reading JSON file or CSV file? We are again reading a JSON file. So that's the user defined function. The idea of user defined function is simple. You want to modify each row. You will get one row as the input and you give out a modified row. You get one row as input, you output one more row as the output. Modified row as the output. So that is user defined function. Similarly, if you remember, you have sum function, you have count function, you have average function. So what these functions do, this will not take one row as an input and it will not output a modified row. It will take one column as the input. Probably if I say some salary, it will take this whole column as the input and it will give out one value. It will give out one value. Similarly, count will also take the whole table as the input and it will give out one value. Similarly, average. So these are all your aggregation functions, built-in aggregation functions. Sum, count, average. It will take one whole column, aggregate it and give it the result. Usually used with group by functions, group by. Now if I want to do my own aggregation, some kind of a aggregation, here is a question, but with map function also we can do some like I didn't understand the question, Samir. With the map I didn't understand. Right. The map higher order function also you can use for user defined function, you are saying, right? Not the aggregate. Right, we can use the map higher order function also, but it will be slightly different. You remember, because everything will be a row object, so you extract the row object from that and you keep on adding. Now you have to deal with only row object. You will not have the actual column names. Such types of things will not be there. But that also could be used. There is no difference at all. You either use a user defined functions or you can write your map higher order function and transform it. But only thing is you will be dealing with now row object. That should be fine. No difference at all. So what Samir is saying is, instead of writing, if there are many columns in a row, UDF will be better, right? I don't know whether it will be better or not. Both could be. I am really not sure, Sandeep. Even multiple columns could also be used with the map higher order function. I am really not sure. Yeah, what Samir is trying to say here is, I will just give an example here. Instead of writing a user defined function, so what we can do is val increased df is equal to, you can take the sales df, get the RDD out of that. Now when we get the RDD, you don't go through the that one thing I can say, you don't go through the catalyst and the tungsten. Probably it may not have a good optimized solution. On that we do a map transformation. Take each element is a row object. From that you again form a row object. It will be slightly different. Row object, then again you create a new row object where r dot 1 will remain as it is, get as field name. I hope you are getting where I am going with this. Customer ID, this is the first parameter. So on the other parameters we'll give. The last parameter what we'll do is we'll just add 50 to that. R dot get as amount paid and we'll say plus 50. As you can see, it's not so elegant. It's not so elegant. You get all other fields as it is. You put other fields as it is. The last, the amount paid, what you will do is you'll add extra 50. So that again you'll create a data frame and again do a 2DF. Then again one more create. I think you have to get the RDD from first, add this 50 rupees and convert it back to a data frame. So whatever transformation you will be doing, it will be done on the RDD. It may not be as efficient because it will not go through the catalyst and it will not go through the tungsten. But we can write in this fashion. But wouldn't recommend that. I wouldn't recommend doing that. I hope Samir that was clear. Yeah. Coming back to user-defined aggregate function. Coming back to user-defined aggregate function. As I said, these are all the normally built-in aggregate functions and they are usually used with the group by functions. Now if at all I want to write my own user-defined aggregate function, so there are no built-in aggregate function to solve my problem. So I want to write my own aggregate function. So how can I write it? So we will see how to write a user-defined aggregate functions. Now we have learnt about data frame. We also know what is data set. So data set is actually associate a class name, case class with your data frame. Associate a, a case class with a data frame which will make it as a type safe, which will make your data frame type safe, and you can apply functional programming style and relational programming style. So data set is nothing but both data frame and RDD functionality is available under the data set. Now everything is data set you can think of. Everything is a data set. Meaning data frame is nothing but it is a data set of row object where you don't know the type of your object. You don't know the type of your object. So data frames are untyped, we can say, because data set can be actually data set of row. Otherwise, normally data set will be data set, and you will know the row, each row object. We can have a data set of sales. We can have data set of users we saw in the accumulator example. In the accumulator example, if you remember, we saw that it is a data set. Now data frames are also data set. We can say it as a data set of row object where you don't know the type of each row. Hence we call it as untyped. Here, since we associate a case class with our data frame, we get the type for each row. So we usually call these as type safe or typed, we can say collection. It is untyped, this is typed. So I hope you got I was able to convey it correctly. Now when we have such a thing, you have UDF defined for untyped UDF, you have UDF defined for typed UDF. So this is on data frames where you will not be knowing the type. You have to use the struct type, all those stuffs here. And here you will be knowing the type, so you can directly use some case classes. So we'll see these both and we'll see how it looks like. Once we see the code, I think everything will be clear. But just remember what is a typed data and what is untyped, because data frame is nothing but an a row object, so we can think of it as a data set of row object. So keeping this in mind, we'll see our user defined aggregate function. So that user defined aggregate function is in Spark 2. Example experiment. It is not in the Spark SQL project, it is there in the Spark 2. Example experiment. So if you go to, I think where I have written accumulated testing. If you go, no testing, it is there in the UDAF, user defined aggregate function. So if you go to user defined aggregate function, there is type safe user defined aggregate function, and one more is untyped aggregate user defined aggregate function. Now let's first see how to write a untyped user defined aggregate function. Simple example I will show here, my average. You want to compute the average is already existing, but let's see how we can write our own user defined aggregate function. Now this is a slightly a bit complex. So you have to define your class or object. You can define my average user defined aggregate function. It should extend user defined aggregate function. This is a built-in class, right? Abstract class it will be. So it is a built-in abstract class. So your user defined aggregate function should always extend this. And there are certain methods that has to be implemented. Input schema, buffer schema, output data type. This is your final output This is your input. This is the intermediate buffers data type. I'm not sure about this deterministic. I need to again check on that. Here you initialize the buffer. Your buffer means your intermediate buffer. Sorry, your intermediate buffer. So that you initialize. This is where you write the logic to update your aggregation. This is where you write the logic to aggregate. This is where you merge from two partitions. You merge from two partitions. The idea is this. The idea is this. And finally this will give the final result. This is update that happens within each partition. Now each partition will have some value, and this is merging two or more partitions. And finally evaluate will give the final result. So let's understand how whole things work. So I have a program, I have a data called employees.json. Let's see how it looks like. Yeah, audio was lost. I think now it is back. So we want to compute the average of our salary. We have name, age, city, and we have salary. I want to compute the average. We can use the normal built-in, but I am just trying to showcase how we can write our own user-defined functions. So we have defined our user-defined aggregate function. Then we register that user-defined aggregate function, and we give a name for that. This name will be used in our select query. Select my average and pass the salary to that. Pass the salary to that. Now let's understand the individual thing. How do we compute the average? How do we compute the average? The logic is total sum and compute total record count. So obviously sum divided by count, you will get the average. So this logic we will be using. So my average, what it will do is, so you have to, your input schema will be, input will be this. This is your input. Input is, what is input? Input is double. Input is a, so you will have double type as your input schema. So you have to define as a struct type. Because it is untyped, you have to use struct type and struct field in this fashion. You can give any name, but its type should be double type. So that's what we have defined as our input type. So if you see here, our input schema is nothing but struct type. Sorry, I had to mention array because it contains only one field. You can give any name. I have long type. Let's check our JSON. Yeah, I have made it, did not make it as a double. So usually if at all it was in this fashion, I would have set it as double. But it is a normal integer. Let's make it as a long type. So that's our input schema. So that's how you have to define. You can give any name for your input schema. Now what is our buffer schema? Buffer schema means the way you will be applying the logic. The way we'll be applying the logic, I mean, you get the input, you get the first input, which is, let's say, 10,000. Internally, how you will maintain it? You will say 10,000 comma 1. Again, next you read the next record. Next record, let's say you get 5,000. So how you will maintain this? You will add these two. You will add these two. You will say 15,000 comma 2. Sorry, 1,000, 10,000. This is 5,000, 15,000 comma 2. As and as you keep on getting new records. What I'm trying to say here is, this is your executor. This is your executor. Task 1 we have task 2, task 3, task 4, task 5, task 6. Each task will be reading its data, and the user defined function will be run by these tasks. So for each task will read first record, and it will maintain its buffer. As soon as it reads the first record, so it will say 10,000 comma 1. As soon as it reads the second record, it will update its to 15,000 comma 2. As soon as it reads the third record, let's say third record is again 5,000 salary, so it will say 20,000 comma 3. So you have some data will be, so it will be keep on maintaining these things. So it will keep on adding in this fashion. Now it has to, since it has to maintain these things, so it needs to define a schema for this. So schema will be these two schema. So this will be long, and this will also be, we can say, uh, number of records could also be long or integer. So that's the buffer schema. So if you see the buffer schema, one is sum and one more we say as a count. We have two columns now. Array of struct field. First column is sum, second column is count. So I hope you got the idea how the buffer schema looks like. And what will be our final output? What will be our final output? Our final output will be, total sum divided by count. So obviously it is double type. So you just have to specify double here. Our final output is double. Now we know that what is our input schema. Now we know that what will be our buffer schema. So our buffer is what keeps on updating. So initially our buffer will be, both will be 0 0. Both will be 0. As you read the first record salary is 10,000. So our buffer will be updated now to 10,000 comma 1. Then we have our next record as 5,000. So our buffer will be updated to 15,000 comma 1. Our next record will have again 5,000. So our buffer will be updated to 20,000, so this update for each task, for each partition or whatever we can say, is done in the this logic will be defined in the update, and initialize will be both the buffers is set to 0 because that's the buffer schema. It has two columns, both the columns buffer of 0 and buffer of 1 is set to, both are initialized to 0. This also we need to write it. So update is where all your logic is done. Update is all your logic is done. So buffer of 0, what it gives? It gives the sum. So this is buffer. It takes the existing buffer and the input. Input is again a row object. We know that. Input is again a row object. From this row object, you get the actual content. From this row object, you get the actual salary plus the existing salary. This will be your existing salary. Add those two and store it back in buffer of 0. And buffer of 1 will have the existing count. Just add 1 to that. So we get the total sum and total count. Now the same logic is applied here. Same logic is applied for every task. Same logic is applied for every task. Now for every task you will have a total and sum. Let's say 1000, 1 something, 1 lakh something. This comes to 2 lakhs, some count, so on. Now these two has to be merged. These two has to be merged. Finally, I mean everything has to be merged. After that, again these two will be merged. Whatever result we get, we have to get merged. Everything needs to get merged. So that's what this merge takes. Merge takes two buffers. This was partition 1 buffer. This is partition 2 buffer. So from that buffer, and you update buffer 1. Always this buffer 1 gets updated. The first parameter of your merge should always get updated. You get the sum from the buffer 1. You get the sum from the other buffer. Add it and store it back in this buffer. You get the count from the first buffer and get the count from the second buffer. Add those two and store it back in the buffer. So merging has happened. So this merge will be done on all the partition outputs. All the partition outputs. And finally, evaluate will be called. Once everything is merged, all the partitions is merged. Finally, you will take the total sum and the total count, and you get the double here. And that's what. And the way we use here is select my average, and we are just giving a average name for this. So I hope it was clear how to use a user-defined aggregate function. Update is where the whole logic will be there, update and merge. Just like if you see, it's almost similar to your accumulators. It's almost similar to accumulators. And since it is untyped, everywhere we have to specify the input schema, the buffer schema, and final output is double type. So let's run this program and check the result. think we don't need, because everything we are hard coding here itself. Local we are saying here itself. So we got the average here by using our own user-defined aggregate function. But this is a untyped user-defined aggregate function. There is no type given here. It is untyped, which is usually done on data frames. On dataset API, you get the type safe or typed user defined aggregate function. So let's see the same example on a type safe user defined aggregate function. So I was just testing some other user defined aggregate function, merchant location. So it's not yet over. Once that is done, I will share that as well. So now everything is type safe. So before I explain this, so the way we get a data set, we know that we use the same, as I'm using the Spark 2.x, we are using Spark session API, and I said that there also we use the same data source API. So we use the data source API and we get a data frame. So this is how you get a data frame. We have already seen. If you want a data set, we can just say in this fashion. This will be RDD. Data frame is nothing but a row object. Everything is a row object. Here is now a data set of employee. We get the type of each row now. So if you hover on wherever it is being used, now you can see that it is a data set of employee. We get the type for each row object. So it becomes a bit type safe. Now how do we use user defined aggregate function? Now there is a aggregator abstract class, and your user defined aggregator must extend that abstract class, aggregator abstract class. Now again, this class has input type, buffer type, and double type. Since everything is type safe now, we can use directly the class, because we know that each record is an employee object. Each record is a employee object now, so we can pass that employee object as a parameter. Your input will be, you can pass the whole employee object. Out of that you can extract the salary. So we will say that input is employee. Average again you can define in this fashion. average, sum, and log. You need not use the struct type anymore. Sum and log, which will be our buffer, internal buffer, and our output will be double, as usual. Double is there. So here there are slightly different methods defined. 0 is the initialize method. Reduce is similar to our update method. So here we have update method. Here we have reduce method. Merge is same. Merge is same. There we have evaluate method. Here we have finish method. Here we have finish. This will, the other things are encoders. Will see that later. So we have finish, which is similar to evaluate here. Merge is as usual. There we have update, here we have reduce. There we have initialize, here we have 0, and there we have input schema, buffer schema, all these things that is not required because is our typed data. So everything is specified here. It's input schema, buffer schema, and output. Everything has a class object. So reduce is where your actual logic happens. So you take your existing buffer will be both 0. Existing buffer will be both 0. Employee is the input parameter. You pass the employee. From the employee you extract the salary, employee.salary, add it to your buffer sum. Because your buffer is average. Buffer is average. Average has a member called sum. You add that sum to that and add 1 to the count member of the average. So it is much simpler than the user defined aggregate function or untyped data type. Similarly, merge is nothing but we take two averages from two different partitions. We take two averages from two different partitions, the first average and the add it to the, as I said, always buffer one will be the returned one. This buffer one will also always be returned, so you have to update always the buffer one. Buffer 2 count, add it to the buffer 1 count, and finally return the buffer. Similarly, we have finish. Finish is similar to the final result. Average dot sum to double, and input parameters just we are saying as reduction. You can give any name. Finish X. Reduction may be a bit of a confusing. We can just say X. So it has total sum and total count. Take the total sum, take the total count, divide it, it should get the result. And the way we use that user defined aggregate function in our main program is use that class name or the object name, to column, give a column name for that. After doing the average, we can give the column. I think why I'm giving 2 times. So this is what we have defined. There is a method called toColumn. Use that and give a name to that new column, which we create a average. And then say data frame dot select dot get the average. So if at all you are using in the group by, sometimes we also need to use it in the group by. So just to group by and then pass aggregate function and then the actual aggregation. So let's run this program and check the result. It should give the same result. So we are getting the same average that we saw in our untyped version. So I hope you got the idea of user defined function. I hope you got the idea of user defined aggregate function. And in aggregate function we have two types, untype and type safe. Now here there was no group by. We just wanted to compute the average, hence we usually don't have group by. So there is one more example. So there is sum of max example. Sum of max example. So where I wanted to show how to use it with the group by. Now let's say we have our data frame in this fashion. This is first row. This is your second row. This is your third row. Again fourth row and fifth row. I want to compute sum of max for each of this. We will treat as something we want to group by. This column will treat to be group by column. For this column we have these three rows. For column 1 we have these two rows. We want to compute sum of max. Sum of max meaning what is the max value out of these three? Max value is 3. Now what is the max value of these? 8. The max value of this 9. So I should add 9 plus 8 plus 3. So it should be 9, 8 is 17. 17 plus 3 is 20 I should get. For 0 I should get 20. For 1 what I should get? 6 plus 7. For 1 I should get 13. For 0 I should get 20. So I want to do this aggregation. Probably such kind of aggregation, built-in aggregation function will not be available in the SQL. So I have to write my own user-defined function. So I convert into a data frame. First column I'm just, for readability purpose, I'm giving it as group me. So group by will be done on the first column. And all these three columns you have to get the values, find out the sum, find out the max out of that, and keep on adding the max for every new row. So obviously now our input will be all these columns. Our input schema should be these columns. So we create an array of C1, C2, C3, and we create a struct type, and then columns dot map we do and create a struct field, and every field we take it as a double type. So we got our schema. I will just say it as input schema, and we use that input schema in our user defined aggregate function. We use that input schema as our user defined aggregate, because input schema will be what we will be passing to our update function, the input to our update function. So let's see the logic how we have defined. It's almost same. So this is our schema, this is what we are passing, our input schema. Use that, associate that to the input schema. Use the same thing, this dot schema, and so input schema is nothing but three fields. What will be our buffer schema? Buffer schema is nothing but one field which will give the sum. Buffer schema is nothing but one field which will give you the total sum for each row. Finally, our output will be the double type. So the logic remains the same. Logic remains the same. So we have our buffer. Buffer again, we are initializing it to 0 because we want to just compute sum. We take the first input. What does the first input will be? First input will be this. It's the same way it works. So our input schema is nothing but all the three columns. So it will be 1.0, 2.0 and 3.0. Input is 1 dot, I will say 1.0, 2.0 and 3.0. This is our input. Our sum is 0.0. Our buffer is we have initialized to 0. Now we have to compute the max of this and add it to this. What is the max of this? 3. So that's what we are computing here. In the update function, our existing is 0. Our existing is 0.0. Then we loop through that, loop through the 0 to input, get all the, because all are in the form of struct type. So you have to get double. Everything is get double and compute the max. And everything is a row object, if you know. From the row object, get the double type for every record. For every column, sorry, not every record, for every column is a double column. We just say input dot input. If you know, it is a row object. Row object get double will get the first column, second column, third column, because we are looping from 1 to 3 columns. We are looping from 0 to that column, and out of that get the max. And add it to your buffer and store it in the buffer. That's all the logic is all about. As soon as we get the next record, again we get here, it will be 3.0. As soon as we get the next record, we'll say 2.0, 8.0 and 5.0. So here we compute again the max of this and add it to the existing one. Max is 8. 8 will be added to 3, so you will get 11.0. Now your buffer will be 11.0. Similarly, next record we have 9.0, 8.0 and let's say 3.0. So max of this is 9. Again 9 will be added to the existing one, so you should get 20.0. This is for the column 0. Next we get 1. Again for the one column, one more buffer will be, new buffer will be created. For one new buffer will be created, that buffer value will be initially 0 and it will keep on updating. So a buffer will be created, everything will be created for each key. We can think of it as a key. For each key, that buffer will be created. Everything will be created for each key. Now finally how we use it, as you can see, this we had not seen. Group by this column, and use aggregate. What type of aggregation we want to do? It's not a sum aggregation or count aggregation, it's our own aggregation. Use that our own aggregation. My max UDF, and pass all the columns. Now this is a bit strange. This I will just try to explain what is this, because it will be very handy most of the time here. So we take the columns. Our columns is nothing but C1, C2 and C3. C1, C2 and C3. Instead, this is a bit confusing. I will just say this is much. One second. This also requires functions. That call is again defined. That call function is again inside the functions. As I said, it never gives you have to always remember these things. Import everything from that. I think, yeah, now it is, error is resolved. So we this requires the whole schema. We have to pass the whole schema here. How we are passing the whole schema here? The columns, I mean, the columns has to be passed, but the columns has to be passed in the form of call. So what we are doing is we are having an array of C1, C2, C3, C1, C2, C3. Just a list you can think of. We have array C1, C2, C3. All these are string. We need to take this string and convert into this. This is a string. We have to convert into a column object because it expects always the column object. Now you have C1, C2, C3, but wrapped inside a column object. This is a column object. There will be some columns here. Just for you can think of in this fashion, because there are a lot of wrappers, right? You can think of there is something like in this fashion. So what we are just trying to do is, if we have a list or array, we have all these columns of array of C1, C2, C3. So we are just saying columns dot map, and we take each record and convert into columns, convert into this class object. So that's what we are doing. So here we take each record, some element, will say each element, and we say create column of that element. So this is what we are doing. Now it was array of string, now it has become array of column, because internally Spark does not understand strings. Internally Spark has its type called as column object. So we are just converting into a column object. So it takes each row and converts into a column object. Now we have an array. Here, but my UDF does not take a array. This does not take a array. It takes a columns, individual columns. Now underscore star is nothing but how do I make this understand? So I will go back to Scala example one more. Let's go back to Scala example. Let's say I have a function called total. Now this total takes variable number of arguments. I will say element int star. It takes variable number of arguments. I mean, I can pass any number of arguments to this, and I can just run a for loop on this. I take each element from this elements, because elements will be now multiple arguments, and I can, before I say this, I can say where sum equal to 0 for each element taken from loop, iterating from elements. I can just say sum is equal to sum plus element, and finally return sum. A simple function. This is how you define a function to take variable number of arguments. Now to this total, I need not pass anything. Because it's variable number of arguments. I can pass only one parameter, or I can pass any number of parameters. It expects the variable number of arguments. So this is how we can pass parameter values to this function. So this is how you define a variable number of arguments. Now let's say I have a collection. Of something, collection of numbers. Now I want to pass this collection as a parameter to the total function, such that first element will go as first parameter, second element will go as second parameter, third element will go as third parameter. That, but you cannot say total of sum, because total does not expect an array. It expects variable number of arguments. So this will throw an error. Saying that found a collection required was integer. Now how do we pass the elements of a collection as individual parameters to this variable number of argument function? The way you do this is, there's a strange syntax. You say colon underscore star. So when we say in this fashion, the elements of this collection will go as individual parameters to this function. I mean, there is no logic to this. We have to just remember this syntax. So it will take all the elements, and our logic is to add all the elements. Obviously, we are getting 100, and that's what I am doing here. So this does not take an array, but it takes all the struct fields of this array as individual columns, and that's the one we are trying to do here. Sometimes we have to use all these tricks. Finally, we are our aggregation. Let's run this program and check the output, sum of lines. So this is our actual data. This is our actual data. We are doing a group by on the first column. So we can see that column group by on value 1, total sum is 13. On value 0, the total sum is 20. So I hope you got the idea how to write a user defined aggregate function and how you can use with the group by or without group by also. Usually most of the time, most of the aggregations are done for each group of data. So usually it will be with the group by. So I assume to some level the user defined aggregate functions were clear. You just try out these examples. I hope it will be clear. Thanks. I think we will wind up the session here, and tomorrow we'll start with the Spark streaming. In fact, we'll start with the Kafka. We'll start with Kafka. Yeah, thanks everybody, and have a nice day, and good night others. Thank you.